Hello, welcome to your direct variation video. This special segment is on d equals RT, which is distance equals rate times time. You will be able to solve for the variables d, r, and t and write the direct variation equation that goes with it. First question is, how do I solve for d, which is distance? Here we have an example problem. A cheetah can run at a speed of 60 miles per hour. How far can it run in 1/4 of an hour? So what you're going to do is use the direct variation equation, d equals RT, and I'll just write that off to the side here. And that means distance equals rate times time. And what we're going to do is drag and drop the information in. So if I have d equals r times t here, distance, that's actually what I'm trying to find because the question says how far. That's a distance thing, so that's going to stay d. R is my rate. Remember, rate has to have two labels, and the where I see two labels is miles per hour, which is actually even unit rate, but that number is 60. And then multiply that by the time. You need to make sure that you're still talking the same labels. So miles per hour, it can go 60 miles in 1 hour, and then my time is 1/4 of an hour. My labels are accurate, so I can just keep 1/4 of an hour, which is 1/4. You could also say 0.25, either way. And then you can do the math here. So 60 over 1 times 1/4 is 60 over 4, and you can just simplify that down, which gives you 15. So then d equals 15, and then we'll want to put a label on it. We are talking about miles, so 15 miles is how far it can go in 1/4 of an hour. Next question, how do I solve for r, which is rate? Our problem here states Joan is on a bike trip. She plans to ride 9 miles in 45 minutes. At what rate must she travel? So again, we're going to use our d equals RT formula here. And this is kind of just a mixture of algebra too. That's another way to think of it. But you're going to drag and drop in your numbers, or evaluate is what is the correct math terms. But what you know. So she plans to ride 9 miles. That's distance. So I'm going to put a 9 here for the letter D equals, and then in 45 minutes. 45 minutes is time. So I'm going to put that here, and then my rate is actually what I'm trying to find, and that's, you can tell that from the question. It says what rate must I travel, or she travel. So that's going to stay R. So basically what this answer is saying is what number times 45 will give you an answer of 9. You can also just use algebra, which is pretty slick here. Divide by 45 on both sides. And using a calculator, you will get an answer of 0.2 equals R. Now we're talking about rate, and rate needs two labels. So I'm going to look at the labels that we were talking about here. So it's going to be 0.2 miles per minute, because that was our label. If we wanted to convert this to miles per hour, which is usually how we see things, we would have to change it from 1 minute to 60 minutes, which is 1 hour. So take that 0.2 and times it by 60, and that will give you 12, which means she can go 12 miles per hour. So 12 miles in 1 hour, and that's typically how we measure things, as miles per hour instead of miles per minute. The last question is, how do you solve for t, which is time? A garden snail can travel 300 miles per hour, which is extremely slow. How long would it take to travel half of a mile? So what you're going to do is, again, use your equation, d equals r times t, and fill in what you know. We see here miles per hour. That should automatically have a flashing light going off in your brain saying that is rate. So we're going to write that down for R, 0.03. And then the next thing that we see is traveling a half of a mile, and that is very clearly distance. And our labels do match up because we're talking about miles in both our rate and our distance. So we can just say 1/2. You could also say 0.5. It doesn't really matter. And then how long would it take is the question that's talking about time. And then we can just solve this algebraically is probably the easiest way to go about it. So we are going to undo, so divide by 0.03. And so this might get a little confusing to you. You can see 1/2 as 0.5 if you want to, and use a calculator. So 0.5 divided by 0.03 equals, and that will give you an answer of 16.6 repeating for T. And then of course we have to label that. How long would it take? Well, we have to go to our rate to figure out what our time label is, and we're talking about hours, so it would be 16.6 repeating hours. So 16 2/3 hours it would take a snail to travel half a mile. Now it's your turn to solve this question. In 1932, Amelia Earhart became the first woman to fly solo across the Atlantic Ocean. She flew at about 135 miles per hour for 15 hours, so how far did she fly? Go ahead and answer that question. Please fill out a Google form for this. So see my website for that. Please do not forget, because that is how you get your points for this stuff. So make sure you fill out your answer. That is the end. Thank you for watching. Have a great day.